In the last session, we discussed few concepts, few design patterns, but with your question, I have a little clarification, because these can be design patterns as well as architecture patterns. Some of our design patterns, some of our architecture patterns. So, distinguish is almost is a thin line, okay? But generally we categorize this if what we are implement within the code where it implementing a particular function, then we call as a design pattern. For example, circuit breaker, factory we did not discuss, right? But if we have something which is affecting the application wide or a system wide, we call this as an architecture pattern. Okay. So, that is the kind of a norm definition. So, somewhere someone else might be defined this some in a different way, but this is a one way to define it. So, last time we discussed few things including load shedders, back pressures and circuit breakers and so on and so. Today we are going to discuss some more advanced patterns where mainly impacting on the data, right. Not all are impacting on the data, mainly impacting on the data. If you get the traditional application, let us say monolith application, right. Monolith application, you are going to create an order, right. So, you need to write to the order table, okay. You need to write to stock table, right. You probably need to update the customer table, right. There are 3 tables need to update, right. Let us say this update is success, this update is success and this update is fail. That means there is an order, then order reduce the stock, but there is no customer for this, customer does not update it from the order, it is a problem. But in the monolith application, all these are run in the same context, right. So, we can easily do this with the transaction handling. What you do here, begin transaction and then commit transaction. If something happen, we roll back, okay. Something happen, we roll back. Now, order table success, stock table success and the customer table fail, now we roll back everything. So, nothing happened, okay, nothing happened. So, I have seen sometime developers write queries putting the statement called read uncommitted, right. You can say select read uncommitted. This is very bad, this is okay for a development, but I have seen sometime without knowing what this is, people pushing this to production. What the read uncommitted mean, typically it do the dirty readings, it can read the uncommitted transaction. The uncommitted transaction anytime can roll back, right. Why they do it? This is very fast. When you put the read uncommitted, it is very fast because it does not acquire locks, right. So, you Google somewhere saying your query is slow, someone give idea like okay put the read uncommitted, you put it okay yes query is fast and you ship it to production, right. This can give the dirty reading, that is a side note, right. That is the uncommitted mean, begin commit, right. So, now this is easy, okay, this is easy. I am not going to discuss about the acid principle and everything because you are graduates and I hope you guys went through those. Now, when it comes to the microservices, we worse this problem, right. For the order, we have an order service. For the stock, we have an inventory service. For the customer, we have a customer service. So, these are separated services itself, right. These are separated services. That means what? if you are following the practice, they have a separate database. Even if you go with the concept we discussed about the domain driven, still they are in a different domains. They have a different databases. Okay. So now you submit the order saved on the order database. It's a different database, right? Now inventory saved on inventory database. Now customer using the request to customer service, it failed. Now you cannot roll back. Why? We discuss in the microservice world, this service is like a different country. They act independently. It's complete independent behavior, right? So there is no way you can delete it now or roll back it now, right? So this is called distributed transaction handling problem in a microservice. Microservice born with this problem because it's natural. Okay? But now the thing is how we can handle this situation. We have a pattern called Saga, right? We have a pattern called Saga. What the Saga pattern does is, it create a way you can deal with this type of a situation. Okay? So one is called orchestration mode, another one is called choreography mode. Okay? What the Saga pattern does is, okay, right, you have a problem, distributed transaction problem. So now you implement the code in the Saga pattern. In the orchestration pattern mean there is a orchestrator service like this, right? Like the question he asked yesterday in the aggregator pattern, do we have a separate aggregator service? Then I said no, don't do it, right? It's the same thing. But here there is something called orchestrator. Orchestrator doesn't mean orchestrator service, it's orchestrator. Okay? What the orchestrator does is, orchestrator says, hey, save the order, right? That order says, okay, I saved. Okay, save the inventory. It says I saved, right? And then save the customer. It says no, customer service failed. Now what it does is, it sends the request to cancel the order. It sends the request to cancel the order. That's what orchestrator does. So what is there's other pattern very similar to this. What is the pattern? Scatter, no, it's not a scatter gather. Chain, right? It's a centralized chain pattern, right? So you talked, but here this is not a chaining pattern. Why? Because we are not expecting a response and take that response to call to other one. But so now it call order cancellation, though inventory reverse or something like that. That is why it's a orchestration. He is responsible to deal with this situation, how to recover something. Now there is a possibility when the order cancel call that fail, right? That is a possibility. So then it need to see how we are going to handle that. But that's the principle. What is the main disadvantage of this? What is the main disadvantage of this? We introduce single point of failure. If the orchestrator fail, everyone fail. Right? If the orchestrator fail, everyone fail. The other model is choreography. Choreography mean there is no orchestrator. This is centralized brain. This is called centralized brain. Right? The choreography mean there is no centralized brain. Order create and it emit the event call order created. Right? It emit the event call order created. So now inventory service listen to the order created event and it go and update the inventory. So now it emit event call inventory updated. right? And then customer listen to that and customer emit an event, customer listen to this and customer go and update the customer. So now if your logic, if your flow is supporting when the order created customer can update, it is totally fine. You don't have to listen to this one, right? If your business logic is okay, order created, you don't have to wait for this one, you can update this, you can listen to this one. But the point is, it will listen to an event. It will listen to an event and then pick the event and do whatever it needs. The one advantage is there is no central orchestrator. The disadvantage is no one knows what happened to the whole picture. There is no one knows it unless you implement the monitoring mechanism to figure it out what happened to the flow, right. The other advantage is when the order created, it is not necessarily inventory update, inventory service up and running. It will emit an event. If this is down, it is fine, independently deployable. They may be down for a deployment, it is fine. When they come back, they can pick that event and do the update. But here in the orchestrator pattern, you talk to this one, if the inventory service is down, it cancels the order back. Okay. So, always architecture patterns are trade-off, right. So, now when you see this, you will feel, okay, so this is the one to go. Why even talk about this, right. But to implement this is a massive infrastructure. You need the message brokers, right. You need to message consumers. It is not a massive, but it is a more effort to do it, right. And software engineers should thoroughly know about the event-driven architectures and everything. But for this one, it is a simple API call. It is the same example. You can use a food cycle to bring the bread from the shop, or you can use a 10-wheeler or a Mercedes-Benz or something. The point is, the thing is whether it is really necessary. That is why we have a different way. It is not that one is better than the other one. It depends on your use case. So, next one is this. This is called TCC. Try, confirm, cancel. Right? Try, confirm, cancel. What it means, you are trying to do something and then confirm if the subsequent action is success, and then if not, cancel it. Remember the seat booking problem? Okay? You hold the seat, try for the payment. If payment is fail, you cancel it. If the payment is success, you confirm it, right. So, that is why I call try, confirm, cancel. It is very straightforward, right. And now the problem is this, you go with the previous one. So, you create the order, right. So, it is not that you save in the order, you set the order in the unconfirmed state, right, and then you take the payment, you update the customer and you confirm. The problem, what is the problem of this model? What is the problem of this model? Let us say airline ticket booking, same thing. You book the ticket, right. So, now when you have to fill so many information, right, you fill passenger information, your baggage information, passport detail, visa detail, everything, it takes some time, right. But this is a potential booking. So, you hold it and then if the within the given time it is confirmed, it is filled, it is confirmed, otherwise it is cancelled. What is the problem with this approach? What is the problem with this approach? Yeah, until it confirm, others won't see that. Okay, there is other problem. So, now you create the order in unconfirmed state, you did the inventory update, you did the order customer update. When you try to confirm it, it failed because it's other network call. This happened in time, right? In time systems can crash, right? So, then you have something unconfirmed, but still all the records are right. So, this type of things, inconsistencies, this is called inconsistencies, can happen in system, especially in a distributed nature. Okay. So, let us say you in an ATM system, right. So, she transfer money to you, we deduct from her account, we hold in her account, and then we transfer money to your account from our GL, and then we are trying to get the money, that account is, that transaction failed. So, now you got the money, she has the money, right. Eventually my bank GL is lost. So, then those type of eventual inconsistencies can happen. So, then we need, when you do, because this pattern does not say that, but in the practical world when we implement in this, we need something like some processors time to time go and check the inconsistencies. Why, what we do is, let us say when you try to confirm, if the confirmation fail, we send the special message saying, we store the special message saying this confirmation, we try to confirm this, it failed, right. So, now we need to design, let us see this what happened. Huh? So, this is the database, there is a order table, right, there is a order table, and then you hold the order, and then you do the inventory update, you do the customer update, you are trying to confirm. When you are trying to confirm, that fail, because database is offline or something, right. Now, you are creating other record saying this could not confirm, there is unconfirmed record, but if you are storing that in the same database, then you cannot store that also, right. That is why the architects and software engineers should have a brain, right. So, you have to have a different media, different way to store this, probably redundant media, right. So, you send an event to a Kafka, or worst case you put a log also, because log is very unlikely to fail, no matter what happened, usually logs works, right. So, likewise, or you maintain a checklist, right, when you do something you checked. So, other than this confirmation you have a checklist. So, now you can go through the checklist, the list is not checked. So, now the whatever the process doing to this optimization or this consistency checking, it says okay, this is not checked. So, that means there is a unconfirmed transaction. Okay. So, you need to come up with some sort of a way to handle it, but this is a good design pattern where you can handle distributed transaction without going to complicate like a Saga. Okay. Because Saga, the problem is Saga, if you go with orchestrator, it is easy to debug, right. But if you go with choreography, it is hard to debug, because it is a clustered event and everywhere. Unless you have a really nice correlation ID implementation or something, it is really hard to debug.
The unconfirmed transaction, so it considered as successful or failure, like if I am booking an airline ticket.
No, it's incomplete until it's confirmed, right? Until everything is happened, it's incomplete. So, it depends, because for example, your seat is confirmed, right. So, now what happens is you pay the amount and you update the customer information and everything. So, when you are trying to confirm this ticket is confirmed, it is now it failed, right. But all your steps are done. So, that is why I mentioned there is a checklist, you can maintain a checklist. So, based on the checklist you can make the decisions, though that confirmation has not gone, but since the payment is made, you consider this as a confirm. It is a case by case. So, step by step we are going to like little complicate design patterns. Huh? So, this one is called event sourcing. Okay, event sourcing. So, this is how this works. Okay, see carefully. Now, in a Saga we learn, we emit event, order created, we emit event, right, and then inventory service listen to the event and store the record, right? That is what happened, and then that emit event, okay? And then customer service did it. So, event sourcing, instead of, he will understand this very properly, easily, right? Event sourcing, instead of telling what happened, it emit the whole event itself, right? It emit the order, the entire order emit as an event. We store the event, we do not store the something in the database as a data, we store the entire event, right. So, now for example, let us say what is happening to your account, right. There are two ways you can do it. So, your account balance is 0, okay, and then you add the 1000 rupees. So, your now account balance is 1000, right. So, you add other 1000, your account balance is 2000, right. You withdraw 500, so now account balance is 1500, like that. That is a value. But other way you can do it, you add 1000, right, and then you add other 1000, and then you withdraw 500, right. You keep what happened as a separate record, okay. So, then when you need, what you do is you run through this, process this and get the results. So, advantage of this is you have audit trail inbuilt. You know exactly what happened, when happened. You know exactly what happened and when happened, because audit trail is inbuilt. You do not keep the results, you keep the event, that is called event sourcing, okay. So, the disadvantage is, if you have a this way, you have a straightforward results, right. But when you have a this, you do not have a straightforward results until you process it. So, that is a disadvantage, but advantage is you have any time you can replay. For example, let us get the some system like a Facebook, right. You create a post and someone create a comment. Instead of this putting into the this one, attaching to this one, you store the comment itself separate event. Now, comment deleted, that is also other event, and someone else added comment. Now, comment edited, everything is a separate event. So, when you want to show it, you just replay the events. The advantage is this, other advantage. Now, here you can tell what is your bank balance, but this way you can tell what is the bank balance as at this date. What you do? You take the open balance and do all the plus and minuses up until that date. So, most of accounting system run like this, because you need to get the asset reports. Your stock as at 31st March, something like that. So, in order to do this, you need event sourcing, okay. So, the beauty is you can take the from today and backward to particular date, or you can take the open stock and open balance and replay. So, let us say in any inventory system you have a open stock take. When you do stock take, you have open stock, right, and then you can all the GRNs and issuance, everything you can replay, and you can tell as per the system by 31st January this should be your stock. Event sourcing. Event sourcing mean you do not store the results, but you store the event itself and then you replay it, okay. Disadvantages are there because you need to put a lot of effort to replay it, and it take time to process, depend on the number of event, depend on how complicated events, okay. Sometime we do is we store the event, we store the process results as well, but you need to be very careful when you are doing that. So, you create inconsistencies. In case you have an event and then you have the results, and if this is not tally, you do not know which one is correct, right. So, more different form of storing create different form of problems.